All right. Welcome to the segments formed by tangents and secants, level 4. Now, in example 1, we want to go ahead and find the line segment DC. And I always want you to kind of annotate where is it that we're really looking for. So I look right here and I see, okay, DC is that entire length. So just know right up front, it's not good enough to find X. We're going to have to plug X back in and find out what DC actually is as a total. Okay, so let's go ahead and tackle this. We look at this, we know we're talking about segments, so we want to go to our formula chart and look at one of the bottom four different formulas. And in this case, what you're going to see is something similar to this. We have our first line right here, and if you'll remember from our other videos, is this a secant or a tangent? Let's see, DE must be a tangent because it only touches the circle in one point. So we're going to look at DE. And when we look at our formula chart, what are they doing to the tangent? Well, every time they're going to square it. So say DE squared is equal to, we then look at the formula chart, and the order that they have it is they actually look at the whole segment, but I like to put the external piece first. So right here we have DF, that's our external secant. Remember, this is a secant because it is touching the circle in 2 points, right here at F and right there at C. And then we have the whole secant, which is going to be DC. And by the way, remember, this is what we're actually looking for. We're trying to find DC. So let's go ahead and plug in the things we know. We know that DE is going to be this 16. So we'll write 16 squared equals, we see here our external secant, the secant on the outside, DF, is going to be 9 times, and this is where things are going to get a little bit tricky. This is why this is the most difficult version of the problem. We want to know what the whole line DC is. Well, when we know both segments, what do you have to do with both segments? That's correct. You have to add them up. So right here we have 9, we have X, and we'll simply write 9 plus X. And I think this setup is the most difficult, but once you do this, it's pretty straightforward. So let's see. Right here we have 16 squared, and we know that 16 squared is really 16 times 16, which would be 256 equals. And then right here, well, remember, whenever we have a number outside of a parentheses, we always have to distribute. And so 9 times 9, of course, will give us 81 plus, and what is 9 times X? Well, that's going to be 9X. Now we simply have to get the X by itself. So what is the opposite of a positive 81? Yeah, of course, negative 81. So what we do to the right side, we have to do to the left. And then we'll just do 256 minus 81, which gives us 175 equals, don't forget we have our zero pair there, it goes away, equals 9x. Well, remember, whenever we're trying to get x by itself, we have a number in front. What do we have to do? We have to divide. So we divide both sides by 9, and it turns out that 175 divided by 9 is going to equal 19.4 repeating. So in this case, let's just say this. Let's say we have x equals 19.4. X equals 19.4. Now from there, though, we're not actually done. Remember, our ultimate goal, and here, let me switch colors for this UT burnt orange. Our ultimate goal is that we want to find out what is DC. What is the total length of this line? Here we notice we have an X, here we have a 9, and remember, we just want to add these two things together. So we'll simply say, okay, 9 plus, and I'm plugging this in for X, 19.4, and let's see, what is 19.4 plus 9? That'll give us 28.4. And in this case, we would say that DC is equal to 28.4. Alright, go ahead, pause the video if you need to finish writing those notes. But I'm going to clear this off and we're going to move on to our example 2. Okay, for example 2, let me go ahead and take a look at, I want y'all to take a look at problem number 4 on your worksheet, and we'll do something similar to this. So I want y'all to find, let's see, I want y'all to find HK when we know that JK is equal to 8 centimeters and IJ, oh, I wrote that out of order, IJ equals 9.4 centimeters. Okay, pretty straightforward. Now y'all have a picture that looks something like this, where, what is this line on top? Is this line on top a tangent or a secant? Yeah, correct. That's going to be our tangent. And then we have our secant here on the bottom because we know it touches in 2 points. Now let's see, that's going to be JKH. JKH. And once again, this one's actually asking us to find HK. Okay, so let's see what we know. We know that JK is 8, so I go to JK, I'm going to write 8 centimeters. We know that IJ is 9.4, so let's see, here's IJ, that's 9.4 centimeters. And that's all they really give us. So in this case, it's kind of nice. We don't know what HK is. We can actually just put an X. And then this will allow us to create our formula. Let me go ahead and switch to our different colors. Okay, so we look at our formula chart. We know these are segments because we see a length like centimeters. And we look at our bottom 4 situations. And so it seems like we have this tangent line right here, IJ. So we would write IJ. And what is our formula chart telling us to do to tangents? Well, it's always going to tell us to square them. So say IJ squared is equal to, and then the next thing we'll have is our external secant, JK, times, now remember, for secants, the sooner you remember this, the better. It's always the external secant times the whole. And in this case, the whole would be made up of J and H. Well, now that we have our formula, our statement, we can go ahead and plug in all the things that we know. We know that IJ is going to be 9.4. And don't forget that will be squared. Equals, we know that JK is going to be 8 times. We know that JH, now once again, this is the trickiest part of this problem. We want to know the whole thing, but it's made up of an 8 and an X. So remember, whenever you have 2 segments of the line, what do you have to do with those numbers or variables? You have to add them. And so we'll put parentheses 8 plus X. And this is why this makes this the most difficult version, because this part's a little bit tricky. Now from here, it's pretty straightforward. We know we have 9.4 squared, which is really the same as saying 9.4 times 9.4. And going to my calculator, that gives me 88.36 equals, and whenever we have a number outside of a parentheses, what do we have to do? Well, we know we have to distribute. And so 8 times 8 will be 64. And then we have 8 times x, so we'll have 64 plus 8x. Now, the good thing about this problem is it's the exact same as our last problem. The only thing is over here, the order has been kind of flip-flopped. That's okay. What's our first step? Well, we still want to go ahead and get rid of the constant. So my positive 64, I'll minus 64, minus 64. And let's see, 88.36 minus 64 is 24.36 equals, it's a 0 pair, it's gone, 8x. Oh, what in the world? Okay. Cool. That's our 0 pair, and equals 8x. Now we're one step away from getting x by itself. We know that whenever we have a number in front of the x, we have to divide. And so we'll divide both sides by 8. And it turns out 24.36 divided by 8 is 3.045. So I can write x equals 3.045. Now, when you look at this, you have to ask yourself, are we answering the question? And our question says, can you find HK? And how would y'all describe HK? Well, I look right here. Here's HK. And HK is just the internal segment, the internal secant, the inner piece, and it's denoted by x. Well, we know what x is. X is simply 3.045. So in this case, we have found HK, and we are done with the problem. All right, I hope this helps. Good luck.